Greetings, M squared here, and today we are going to solve some basic exponential equations. So these are the first kind that you ever solve. When you get to Algebra 2, you will learn a different a way to solve this type, which I'm going to talk about in a minute. So right now you don't have enough information in Algebra 1 to do this, but we can do these other ones. So let's make sure we understand the rules, these steps. First of all, there needs to be only one base on each side. So base of 7, 1 on each side, beautiful, ready to go. The bases must be the same, 7, 7, they're the same. If that's true, then we set the exponents equal to each other. So this one's kind of simple, right? If I say 7 to the x equals 7 to the 4th, and there's an equal sign, then I know that x must be 4. It's the only way. 7 to the 4th equals 7 to the 4th, right? So remember, the first thing you're going to check is there one base on each side? Yes. Are the bases the same? No, the bases aren't the same. So although this is possible once you learn something else in Algebra 2, it is not possible in Algebra 1 because we don't go that far, right? We don't learn about logarithms. You need logarithms for that. So we don't learn about that yet. Excuse me. So can't do it yet. Can't do this yet. I'm going to say that because you will be able to do it sometime. All right. So, going to go to the next one. Is there one base on each side? Yes. Are they the same? Yes. Okay, then we set the exponents equal to each other. 2x equals 8. Divide both sides by 2. X equals 4. All right, next one. Is there one base on each side? Yes. Are they the same? Yes, they're both 5. Okay, then I set the exponents equal to each other. So x plus 7 equals 3x. And then I solve that linear equation. So I get all my x's on one side. I get 7 equals 2x. I divide both sides by 2, and x equals 3.5. Or you can leave it 7/2. Doesn't matter. All right, so now we're going to change it up a little bit. Those are like the really basic, simple ones. So now what we learn up here is if the bases are not the same, or they have to be the same. If there is not one base on each side, so one side has more than one base, then we need to use our exponent rules to simplify so it's just one base to one power, right? So you'll see here that I have one base of 2 on this side, but I have 2 bases on this side. They're the same. I can't solve it yet if they're not the same. I can't use my exponent rules if they're not the same. So I'm not going to trick you with that. But they have to be the same to use our exponent rules, but I need 1. I need 2 to some power equals 2 to some power. Well, I know this one's going to be 4x plus 1 because there was only 1 over there. But what do I have to do? So I have to remember my rules, and my rules say that when I'm multiplying like bases, I can add the exponents. So here I'm going to add exponents. So 2x and x can be combined. They're like terms, so 2x plus x is 3x. Negative 5 plus 3 is negative 2. So now I used my exponent rules to get it one base on each side, and once that happens, I can continue like I did above, where I set each exponent equal to the other one, right? Because if these two are equal, then these guys have to be equal. So in order to find x, I just solve that equation. So let's see, I need to get my x's. I'll move my x's to the right side because I noticed that the 4 is bigger than the 3. That way I don't have to worry about negatives. So I get negative 2 equals x plus 1. So I'll subtract 1 from both sides, and I get negative 3 equals x. All right. Now you could always go back and check it by putting a negative 3 in there and doing that resulting. I would use my calculator for that probably. And this one should be equal to this one when you put the negative 3 back in. Okay, so here we go. Now this one's a little trickier because to simplify it, yes, there's one base to each side, but I've got these parentheses and it's raised to a power, so it's kind of tricky there. I can't have that. I need to simplify this first. So my exponent rule says when I have a power raised to a power that I multiply exponents. So I'm going to take 4x times negative 2. So that's a negative 8x. And then I'm going to set it equal to the other side. So although there was one base on each side, can't really count this. It's a little tricky. You have to simplify it. We want to make sure it's simplified. Just one base to a power, not a power raised to a power. So now that they're one base, and they're equal, I set the exponents equal to each other. So negative 8x equals 2x minus 6. I'm going to move, I'll just move my 2x over. I know it's going to be negative, but that's okay either way. Here I go. So that canceled out. Now I get negative 10x equals negative 6. I divide by negative 10. And here's where you got some options. You can say x equals 6/10, which reduces to 3/5. Either one of those. This one would be considered the simplified fraction. Or you could just say 0.6. Either one. Okay, so we did our multiplication, power of a power. Now we're doing our division rule. And our division rule says when you divide like bases, look, they're all the same, they're all 8s, you subtract exponents. So 8, and then it's going to be 5 minus x. Now here is where some people might make a mistake because you have to subtract the entire exponent down there. So I put a parentheses and a minus sign just to show that you have to actually subtract both of those. And you could do it separately too. You could say 5 minus a negative 7, negative x minus a minus 3x. But I like to do it like that. Okay, so I knew that my rule, when I divide, I'm subtracting exponents, right? That's what my rule says. So I'm going to just simplify this by pretend that there's like a negative 1 there. That's one way to do it. Negative 1 times 3x is negative 3x. Negative 1 times negative 7 is positive 7. And that's going to equal 2x. So this whole thing equals this whole thing because the bases were the same. So now I have to simplify. That's a negative 4x. That's a 12. And this time I'll bring them over to this side. So up here I've got 12 equals 6x. And if I divide both sides by 6, I get x equals 2. So this is a little confusing when you start off. But once you set up the equation, it should be really easy. You've been doing that for at least 3 years now. The important thing is that you look at each one and see, make sure you go. Is there one base on each side? If there's not, simplify first. If there is, you set them equal to each other. And when there isn't one base on each side, you have to ask yourself, multiplication, then I add exponents. Division, then I subtract exponents. Power of a power, then I multiply exponents. So you're always using those rules to figure out what you have to do to simplify it, set up the equation, and then get the answer. Good luck. M squared, signing out.